All right, we are going to go over our worksheets now. So we're going to start with the balancing chemical equations worksheet. We'll go through a few of these together. So here we go. Let's start with number one. So we need to see number one. So what I'm going to do, and I would encourage you to do this as you practice counting atoms. So I'm going to make a table. It says reactants and products. This is going to model, I don't want to move you, I'll make you skinnier. There we go. All right, this is how I'm going to model how many atoms of each element are on each side of the equation. So I'm going to take my reactants. Reactants are anything to the left of the arrow. So I have hydrogen and I have oxygen. So now let's count them. I have 2 hydrogen atoms in this diatomic hydrogen molecule, and I don't have any current coefficient, so I'm just going to put 2. Same thing for the oxygen. For the water molecule on the other side, I have 2 hydrogen atoms, not 3, and I have 1 oxygen atom. So as of right now, because of the law of conservation of mass, I have to make sure that whatever goes into my equation is the same exact thing as what comes out. So right now I am short an oxygen. So what I'm going to do first, because I know this has to stay diatomic oxygen, I can't just take an oxygen away. So I need to make sure that I have 2 oxygen as products as well. So I'm going to add a 2 here. When I add a 2 here as a coefficient, it multiplies the coefficient times the subscript. So of anything that's existing in that molecule. So for instance, this 2 multiplies my hydrogen atoms by 2. So I have 2 already times 2 equals 4. Okay. All right. And this O has an imaginary 1. Remember, we don't write a subscript for 1 atom in a molecule. So 2 times 1 is 2. All right. Okay, so that's all well and good. My oxygens are balanced now, but my hydrogens are not. So I have 2 more hydrogens than in my products than I do in my reactants. So what I can do, because I don't want to mess with this anymore, my oxygens are good, we can go ahead and we can add a coefficient on the reactant side, and all we need to do is add 2 more hydrogens, and I can do that by multiplying this molecule by 2, because it already has 2 hydrogen atoms in it. If I add another one, then it gives me 2 more additional hydrogens. So I multiply this coefficient by the subscript, and that gives me 4 hydrogen atoms. Let's do another easy one, and then we'll move on to a slightly trickier one. So let's move on to number 2. We have magnesium and oxygen. Kind of a similar problem here. So we have 1 magnesium on our reactant side, and we have 2 oxygen. And on the product side, we have 1 magnesium, but we only have 1 oxygen. We know that that oxygen doesn't just up and disappear. It has to do something. It has to rearrange itself in some way and form a bond, because matter doesn't, it's not created or destroyed. It just is. It just changes states or changes hands, basically. So how do I ensure? Right now, I need to add an oxygen to the product side. And what I can do is I can add a coefficient here in front of this magnesium oxide molecule that multiplies the coefficient by the subscript. So both of these subscripts are 1 because they're not existent. They're just kind of imaginary. So 2 times 1 magnesium is 2 because this coefficient applies to every atom in that molecule. And 2 times the 1 oxygen atom is 2. All right, that's great. Our oxygens are balanced, but our magnesiums are not. So let's go on the reactant side, and we'll bring this magnesium up to the same level as the magnesium in the products. So all I have to do here is add a coefficient in front of the magnesium atom, and I just need to add a 2, because 2 times the 1 imaginary or invisible subscript here, 2 times 1 is 2. All right, so now we have 2 magnesium, 2 oxygen on the reactants. In the products, we have 2 magnesium and 2 oxygen. So that equation is balanced. Let's go ahead and we'll move to a slightly trickier one. Let's work on this one right here, where we have hydrogen peroxide that is breaking down into water and oxygen. So the elements that are included in this reaction are hydrogen and oxygen. I'm going to change my symbols here. I have hydrogen going in, hydrogen coming out, oxygen going in, oxygen going out. So in my reactants, I have 2 hydrogen atoms in this hydrogen peroxide molecule. I have 2 oxygens in that same molecule. In my products, I have 2 hydrogens But I have 3 oxygens. I have 2 as part of this diatomic molecule, and I have 1 as part of the water molecule, so I have 3. What I'm going to do is I'm going to, first I need to make sure that these are even numbers so they're easier to work with. So what I'm going to do is I'm going to add a 2 in front of this molecule because then this brings this oxygen up to 2. So then 2 plus 2 is 4. It's a lot easier to work with than an odd number. Okay, so when I do that, that 2 multiplies the subscript of the hydrogen by 2. So now I have 4 hydrogens in my product, and I have the 2 multiplies by the imaginary 1 subscript on the oxygen. So 2 times 1 is 2, plus the existing diatomic oxygen. So 2 plus 2 is 4. All right, so what do I need to do now? If I know that each hydrogen peroxide molecule gives me 2 of each hydrogen and oxygen, what I need to do to get to 2 and 4 is I just need to multiply this by 2. So the coefficient multiplies by the subscripts. 2 times 2 hydrogens is 4 hydrogens, and 2 times 2 oxygens is 4 oxygens. And now we're balanced. All right, so let's move on to another one. I work our way through the sheet. Let's do this one where we have calcium and water that yields calcium hydroxide and hydrogen gas. All right, so in this equation, we have 3 different elements that are represented here. We have calcium, and on the reactant side, we only have 1 of those. We also have hydrogen. On the reactant side, we have 2. We also have oxygen. In reactants, we only have 1 oxygen. So if I look at my products, what is going on here? So this is a parentheses, this hydroxide is a polyatomic ion. So this ion has a charge, this molecule does on its own. So when it binds with calcium, it binds as a group. Anyways, when you see this, what I want you to do is take the subscript that's associated with the parentheses, and it applies to everything inside the parentheses, just like an exponent would. So basically think of this as Ca1, O2, H2. All right, so Ca, calcium, we still have 1 on the product side. Oxygen, we have 2 because that subscript on the outside of the parentheses applies to the oxygen inside. So I have, let's bring my oxygen down here. Oxygen, I have 2 of them. Hydrogen, I have the 2, as well as these 2. So I have 4 hydrogens on the product side. I only have 2 on the reactant side. So let's work with hydrogen first. Let's try to bring this side, the reactant side, up to 4 hydrogen atoms. All we would have to do is add a subscript of 2 next to this water molecule, because the 2 times the 2 atoms inside brings us up to 4 atoms of hydrogen, and it also brings this oxygen up to 2, okay? Because this coefficient applies to the whole molecule. So, oh, hold up. That's all we had to do, because now we have 1 calcium as a reactant, 1 calcium as a product. We have 4 hydrogens as a reactant, and we have 1, 2, 3, 4 hydrogens as a product. We also have 2 oxygens as a reactant and 2 oxygens as a product. Too easy. All right, let's move on and do some other hard one. Let's do this one. So in this problem, we have phosphorus and oxygen that combine to make, I'm not quite sure the name of that compound off the top of my head. So we have the common name for that compound. All right, going into this equation, we have phosphorus. We have 4 atoms of phosphorus. Coming out, we have 2 atoms of phosphorus. All right, going in, we have 2 atoms of oxygen and 5 atoms of oxygen coming out. So the first thing I want to do, this is kind of a weird number. So what do I need to do to bring these 2 numbers to the same level? Well, it looks like we're going to have to, because this is just part of one molecule, we're going to have to come up with the least common multiple. So the least common multiple between 2 and 5 is 10. So to bring both sides up to 10 atoms of, of oxygen, we're going to have to add coefficients. So the coefficient we would use on the reactant side would be 2 times what equals 10? Well, that answer is 5. All right. So now I have 10 oxygen atoms on my reactant side. And if I add a coefficient here, 5 times what equals 10? Well, that's 2. So 2 times 5 is 10. All right, it also applies to the phosphorus. So 2 times the 2 phosphorus is 4. And look at that. Now we have 4 phosphorus on the reactants, 4 phosphorus in the products. We have 10 oxygen in the reactants and 10 oxygen in the products. So that one is balanced. Let's do this one. So in this reaction, we have gold, Ag. We only have one of them, the reactants. We also have bromine, one of those. We have gallium, we have one of those. We have phosphorus, one of those. And we have oxygen. There are 4 of those in the reactants, okay? So we have 5 different elements being represented in this equation. So on our product side, we have currently 3 gold atoms. We have 2 gallium, we just have 1. Bromine, we have 3, because the subscript tells me there's 3 atoms of bromine in that molecule. Phosphorus, we still just have 1. And oxygen, we have 4. So right now, some of them are balanced and some of them are not balanced. So let's start with gold, just because it's in alphabetical order. So gold, we have 3 products and 1 reactant. So let's go ahead and add a 3 right here to bring us up to the same level. So all we have to do is say 3 times the 1 gold is 3. And we have 3 gold. And also 3 times the 1 bromine is 3 bromine. And look at that. It seemed complicated, but it wasn't. So we have 3 gold reactant, 3 gold product, 3 bromine reactant, 3 bromine product, 1 gallium reactant, 1 gallium product, 1 phosphorus, 1 phosphorus, 4 oxygen, 4 oxygen. We are balanced. All right. Sometimes it's as easy as just adding 1 coefficient, and sometimes you have to play around with them. So let's go ahead and do, all right. Let's work on 22. All right. So we've got here, we have silicone. We only have 1 of those on the reactant side. And we have chlorine. We have 4 of those on the reactant side. Hydrogen, we have, 2. And oxygen, we have 1. All right. And on the product side, we have silicone is 1. Oxygen is 2. Hydrogen and chlorine both just have 1. So let's work with the chlorine first because it has the most. It just sounds fun. So we need to bring the product side up to the same level as the reactant side. So let's go ahead and multiply this molecule by 4, because that will take that coefficient, multiply it by the invisible 1 right there. So now we have 4 silicone, and we have, I'm sorry, I'm in the wrong spot here. I don't know what I was doing there. All right, so I'm gonna put a 4 here instead because I'm working with chlorine. So now I have 4 hydrogens, and I also have 4 chlorines. All right, so silicone's still good, chlorine's good, hydrogen. All right, so by adding this 4 here, I now have more hydrogen in the products than I do in the reactant. So let's go back to the reactant side and see what we can do to bring this amount of hydrogen up to 4. Well, it looks like I can add a 2 because 2 times 2 is 4, right? So if I do that, that's helpful. And now that also changes the number of oxygen atoms I have on the reactant side. So 2 times 1 is 2. And if you look at that, we are balanced. So let's do 1 more. Let's work on this lead, iodine, sodium one. So go ahead and clear out your table. All right, I have lead, Pb, I just have 1 of those. All right, nitrogen, I have, remember this subscript applies to everything inside the parentheses, so 2 nitrogen. All right, this 2 also applies to the oxygen in here. So we actually multiply these together like we would exponents. So 2 times 3 is 6, so I have 6 oxygens. I also have sodium, one of those, and I have an iodine. It's a capital I. I have one of those. All right, so I have 5 reactants, 5 different reactants, and I will have 5 products. So I have 1 lead. Gracious. Okay, we have 2 iodine in this molecule. All right, sodium, I have 1. Nitrogen, I have 1. And oxygen, I have 3. So let's go ahead and work with the oxygen first, because I feel like a simple multiplication, if I add a 2 here, that could, if I multiply that 2 by the existing 3 oxygen, I can bring that up to 6. But by doing that, I also increase the amount of sodium and nitrogen in my atom. So now I have 2 sodium and I have 2 nitrogen on my product side. All right, well, that was good for the nitrogen because that brought me up to the same level as the reactants. But now I have more sodium in the products than I do in the reactants. So what we can do is go back to the reactant side, look for sodium right there, and I'm going to multiply it by 2 because this 2 will mean that I have 2 sodium iodide atoms, or molecules, I'm sorry, which means I'll have 2 sodium atoms now, and I will also have 2 iodine atoms now. And look at that, we are balanced. All right, so it just takes a little playing with. Sometimes you just have to experiment, play around with the numbers, just systematically go through, make sure everything is balanced on each side. And soon enough, you will get to the point where you can do this without making a table, where you just get so used to counting the atoms that you can just do it in your head. So that is the Balancing Chemical Equations worksheet. I will go ahead and post this on its own, so you don't have to watch through a whole super long video to see just this content. I will post another one for the molar mass calculations. So stay tuned for that. I know you guys are all just on the edge of your seats waiting for me to post that.